Now let's see what is conjugate of Z. Conjugate of Z. So if we have Z equals to x plus I y, okay, so conjugate of Z will be equals to Z bar, and it is defined as x plus minus IY. So that is written as real component of Z minus imaginary component of Z. So this is the you can say a trivial definition. And let's see what do we mean by conjugate of Z. So if we have our complex plane, I think this is our complex plane. Here, this is the real axis, this is the imaginary axis, and we have Z here that is represented by x comma y. Okay. So, and we need to represent x minus y. So Z bar will be a mirror image of this, x minus y, mirror image of Z along the y-axis, real axis. This is what we say conjugate of Z is. There are some properties, so I'll write some important properties. So if Z1 and Z2 are two complex numbers, then Z1 plus Z2 bar will be equals to Z1 plus minus Z2 bar. Z1 bar plus minus Z2 bar. First one. Second one is, you can write these properties on, because when we will do some proofs or when we will solve some questions, we'll be using those things again and again, and these are really basic things. If you know these things already, you can skip these things. Okay. So Z1 into Z2 whole bar will be equals to Z1 bar into Z2 bar, also a simple one. And just the generalization of this, Z raised to power n bar equals to Z bar raised to power n. Okay. The fourth one is that conjugate of Z will be equals to Z. It is exactly similar to the function inverse of the function. Inverse of the inverse of the function is equals to the function itself. So these are basically the four important properties, and there is one division with division operation, that is Z1 divided by Z2 whole bar will be equals to Z1 bar divided by Z2 bar. So this is the thing. Okay, now let's see what is argument. So yep. Now let's see first modulus of Z. So if we have our complex number Z, x comma y, x is real axis and y is imaginary axis, this is our point. This is our point here. Then the distance from the origin distance from the origin to this point Z will give us mod z, that is the modulus of z. And if this is y, this is x, you can easily see that mod z will be equals to under root of x square plus y square. So modulus of z will be equals to mod z and will be equals to root x square plus y square. Okay, so and we have some properties associated with modulus also, so we'll write some important properties. Okay. Number one is z1, mod of z1 into z2 will be equals to mod of z1 into mod of z2. Second property, so I'm writing the important properties. This is a generalization of the first property. Z raised to power mod of z raised to power n is equals to mod of z raised to power n. Okay. The third one is, that is very common, z1 and z bar will be equals to minus mod of modulo of mod of minus z bar. Okay. The fourth property, actually this is important and we'll be using and proving this these properties in our later videos. Mod of z square, the most important property is here, that is coming from the triangle inequality itself, that is mod of z1 minus mod of z2 will be less than mod of z1 plus minus z2, and will again be less than, this whole thing will be less than z1 plus mod of z2. I want you to memorize this property because it is important, and I want you to give me the provement of this property in comment section, or you can post any picture also if you have. So I will be learning about argument or amplitude of z in the next video. Thank you for watching.